All right, good morning from threes. Okay, so today we'll be dealing with this topic on electricity. Okay, we started this topic. I think about 2 or 3 weeks ago. Yeah, and I said this topic would just take us about 2 or 3 weeks. Yeah, but with the closure of schools, it simply may take us some more time than we anticipated because you do know that. Yeah, sometimes online teaching doesn't really much help to physical teaching, yeah, and we can't avoid that fact. Okay, we can't avoid that effect, but we'll do our best, okay, to turn the tables around. Okay, so even if it's possible, we can finish sooner than it was teaching in physical learning. All right, so we say electricity is just a branch of electricity. I know that's the most confusing part. We say electricity is divided into two branches. So we have static electricity, then we have current electricity. If you know that, it means you're 50% into knowing what electricity is all about. Just by knowing the two branches of electricity, that's enough to set off. All right, so under this topic, we're supposed to learn about simple circuits, then talk about other circuit components, then talk about amperes. You know, it's really hard for some to pronounce the word ampere. So what they did is that they just simplify that to amp. So it's the same thing as saying amp, no problem. Amperes. And we'll see what that is. Then we'll talk about current. So current is very important. Then we'll talk about voltage. Okay, then I explain how to measure voltage. Then finally, we'll talk about resistance. And trust me, this topic is really nice and important. You have a lot of experiments in this topic. You have a lot of practical stuff in this topic. So yeah, just hang on, okay. All right. Now, last time we defined what current electricity is, and we said current electricity is a branch of electricity which deals with moving charges, and we said current electricity is also known as electricity. So when you simply talk about electricity, it means you're talking about current electricity. If you talk about static electricity, it means you're talking about electrostatics. And just to remind you guys, we said electrostatics is a branch of electricity which deals with static charges that are not moving. Okay. All right. Now, let's talk about simple circuits. Now, this is a revision to some, and maybe to others they haven't done this here, but I do believe it's a revision to most. Yeah. So a simple circuit has a cell. It has a switch right here, as you can see the switch. Then you have a lamp. Then you have wires. If you connect it in this way and on the switch, put the switch to on position, the lamp is supposed to give some light. All right. Now, what I'll do is I'll try to answer some questions. It says, describe the path of an electron around the circuit in figure 17.1 on this page. As you can see, 17.1, this figure right here. Okay, when the switch is pressed down. All right, so let's examine the switch. Do you see the switch? The switch, what they've done with the switch is that it's just a pressing switch. So you put your finger on that on the black knob. Yeah, I think it's a knob. I don't know what it is. What else you call it? Knob, handle. I think let's call it a knob. Yeah. So a button. Maybe it's a button. So you put your finger on that and press it down. Now, when you press it down, what happens is that those two metal sheets, they join. They connect with each other. All right. When you remove your finger, the metal sheet goes up and it's disconnected from the other metal sheet. What that does is that it connects a joint and it connects the joint. In other words, you just making a wire and then making a gap. Now, in so doing, if there is a cell, the cell will make the electrons to move around. If you remember, we said current is defined as the flow of electrons or the flow of charges around a circuit. If there is a gap electrons or charges can't flow. But if there is a connection throughout, then it simply means that electrons or charges can flow around. Okay. Now, in this case, the question says when you press down the switch. When you press down the switch, it simply means you have made a connection you've made a connection, thereby making a complete conduction path throughout the whole circuit. In so doing, it means electrons will be able to move. Now, what's more important is to know that electrons will move from the negative terminal of the cell around, then through the switch, then through the lamp, then back to the wires, then into the positive terminal of the cell, then goes round again to the switch, the lamp, then to the cell, just like that. Okay. And if let's see the next question before I proceed. It says, question 2a, how does the wire in the filament behave differently to other wires in the circuit when the current flows? Now, do you see the lamp? If you see the lamp, you can see that inside the lamp you have like a wire which looks so coiled, like it's coiled, and it makes a filament. If you have a coiled, if you have a coiled wire like that, okay, in a bulb, it's known as a filament, all right? And the question is saying that how different does the wires behave? Okay, if you talk about, I think that's what the question is. Let's go back to the question. How does the wire in the filament behave differently to the other wires in the circuit when the current flows? They're saying that if current flows in the filament, how different is it when the same current flows in the wires? When current flows in the wires, in these other wires which look black, there is no much effect, all right? There isn't much effect, not really much effect. Apparently, the wires will just be the way they were before. Okay, there's a slight difference of which I don't want to talk about right now, but for the meantime, know that there will be no difference. They just look the same. But if you go to the filament, there's a big difference because the wire in the filament will glow. Glow means to glow means to glow, to have some light on it. So it will glow. It will show some light. B. What property of the wire accounts for this difference? What property of the wire accounts for this difference? That I'll leave it to yourself, okay? I want you to search through the internet, or I want you to search through the books. What makes the filament wire to glow, and what makes the other wires not to glow? Okay, there is a property of that. Just look at the properties of substances, materials. Properties of materials. You can go to Checkpoint Book 1. There is something to do with the properties of materials. Right there you see that you have that property of material, which makes the filament wire to glow and make the other wires not to glow, even if there is current flowing in it. Okay, so today was just introductory parts to these lessons. So next week we'll proceed to look at other parts, and we'll proceed to look at conventional current, because remember that we said there are two types of currents. We have conventional current and you have electron current. And last time we saw electron current, which you say it is a current which flows from the negative terminal to the positive terminal. So next time we'll look at conventional current and see how it flows. Otherwise, have a good day. I want you just to look at the question, what property of the wire accounts for this difference? If you have any question whatsoever, let me know. Goodbye.